So here's the graph. We have a compression and a translation, so we'll do the two sets of arrows. I'll label these 4 points here. So I have -5, 3, -2, -3, 1, 0, and 4, 6. Draw arrows for my stretches. Draw arrows for my translations. And then I'll look, what do I need to do? I need to vertical compression by a factor of 1/3. So above here, I'm going to write y by 1/3. Translations 2 units up. So above that one, I'll write 2 up. My x values are not changing, so I will just rewrite them. Y values by 1/3, this will be 1, -1, 0, and 2. 2 up, my x values don't change again, so I'll just rewrite them. 2 units up, this will become 3, +1, 2, and 4. So I label my points, -5, 3, -2, 1, 1, 2, and 4, 4. Connect the dots. And I've drawn the new graph after it's been compressed vertically by a factor of 1/3 and translated 2 units up. If I wanted to write, so I'm going to add a part B to this one. Let's write an equation of the image graph. In terms of G. So this in terms of G means on the right-hand side of my equation, I need to have G of x. If y is multiplied by 1/3, that would happen outside of the function. And 2 up also would happen outside of the function. Now something interesting happens inside with horizontal stretches, compressions, and translations. So we've done this already with the points and the arrows. We're going to look at doing the same thing with the horizontal question. So I'm going to go to the one that was in the textbook. We're going to do this one as well. I mean, the setup would be the same. I'll do it very quick. You don't have to write this down. But the setup would be, I'm going to take my points, -4, 3, 0, -2, 2, 5, and 4, 2. Set up my arrows. This is exactly the same. And this question has a horizontal compression, x by 1/2, and then 3 units to the left. So x by 1/2, -2, 0, 1, 2. Y's don't change. 3 to the left, -5, 3, -3, -2, -2, 5, -1, 2. So I move them all 3 to the left. I could graph my new points, -5, 3, -3, -2, -1, 2, and -2, 5. And draw my graph. Now, if we wanted to write this equation in terms of G, like, I'm being mean right now, I'm thinking, what's the best way I could trick you? Okay, I'm going to write down 2 equations and ask you which one's right, and you're going to pick the wrong one. And that would be tricking you, right? So I want to point this out because your brain will trick yourself on this many times coming up. So, which of these is right? Oh, I guess in this question, it's F, right? I read the question wrong. It's F instead of G. So we would have to write x by half. That's inside the function, right? Half would be 2, 3 to the left, and there we go. Now it's obvious that one of these is right and one of them is wrong. We're going 3 to the left, right? So which one's right? This one, which should make no sense to you. Don't you want to have plus 3 if it's 3 to the left, not plus 6? Why? Because when it's horizontal, I actually don't like well, this one is completely wrong. This one is right, but feels wrong. So how do we write it so that it's right and it feels right? When you have a horizontal stretch and horizontal compression, it has to be written in factored form. So technically, if I add these brackets here, this one still feels right with the plus 3, going 3 to the left, the 2 for the horizontal compression. But can you see if you distribute this 2, you would actually get 2x plus 6. And there will be questions that are written this way and say, how far to the left did you go? Multiple choice, and they'll have 6 units to the left. It's like, oh. So what I want you to do at the bottom of the page here is write this special note. When we have a horizontal stretch or compression or reflection and a horizontal translation, it must be written there we go. 7 exclamation marks means that that's really important. It has to be written in that factored form because you will be tempted, and it comes up, I'm going to say it's going to come up hundreds of times in this unit when they don't factor it and you have to factor it. Or it is factored and you have to realize, okay, should it be factored or not? I once had a student who set up a reminder on their phone for 9 p.m. every single night. And the reminder would come up, remember to write it in factored form, which worked really well for them, but there's like hundreds of things you have to remember. So if you start putting in reminders in your phone, what you have to remember, you might have 4 hours of reminders by the end of this course. Probably would still be a good thing, but this is one that is, right, star, star. It's super easy to forget. So think about this tonight. Practice thinking about this when you're like waiting for the bus. Go through your mind, say, oh, what do I have to remember in math? This factored form is going to come up. The more times you think about it, the chances of you seeing it and working well with it will increase. Questions for practice, you can circle 4, 5, and 6. Yes, is everybody done on this page? I can go back to the other one.